All right, so 6.1 horizontal asymptotes. These are power driven. Power driven, all right? So what do I mean by that? So I'm going to break these up into three cases. Case number one. Case number one. If the numerator degree is greater, no, I'm going to say less than the denominator degree, then what happens? The horizontal asymptote is y equal to 0. So give you an example of what I mean here. So the numerator degree is less than the denominator degree. So maybe if I had like x squared plus 3x in the numerator, and then x to the fifth plus x cubed in the denominator. When I look at the degree of the numerator is a degree 2. When I look at the denominator, that degree is a degree 5. Okay, look at the highest powered term, that tells me the degree of the polynomial. I don't really care about the other pieces here. The highest power determines what the degree of the polynomial is. Okay, when the degree of the denominator is larger, that is pulling your ratio down to 0 faster, hence our horizontal asymptote of y equal to 0. Okay, case 2. So case number 2, instead of being less than the denominator, if the numerator, let's just say top degree, is equal to the bottom, the denominator degree, then what happens? Then the horizontal asymptote is y equals the lead coefficient of the numerator divided by the lead coefficient of the denominator. Okay? So the horizontal asymptote, we look at the lead coefficients for the numerator and the denominator, and that tells us. So an example here would be like if I had 3x squared plus 5 over 2x squared minus x plus 11, whatever. I look at the lead coefficients at 3 and the 2 here. So that means y is equal to, for my horizontal asymptote, y is equal to 3 over 2. The way you can think about it here, since the degree is equal to 2 here and the degree is equal to 2 here, there's a tie going on between the top and the bottom. So the tie results is determined by the coefficients in front, and it's just that ratio, 3 over 2. Okay? Last case, case 3. Case number 3 here is if the top, the numerator degree, is greater than the denominator degree, let's just say the bottom, then what's the case? Then there's no horizontal asymptote. There's no horizontal asymptote, right? So your example here would be like if I had like 5x to the fifth minus x over 3x squared plus 2. The numerator degree is 5. The denominator degree is 2. So when I look at this, the top beats the bottom. So what's happening? The top is pulling the bottom up to infinity. Okay? So there's nowhere where we just level off and have a horizontal asymptote. All right. So this is kind of a lot to take in. So there's a trick here. Here's the trick. It's kind of goofy, but maybe it'll help you memorize it. Bo, Botten eats DC. Bo, Botten eats DC. Okay? So how does this work? How does it work? Well, Bobo stands for bigger on bottom. And then the last O is Y equals 0. Okay? Botten is bigger on top. The N stands for no horizontal asymptote. Okay? Each DC is exponents are the same, divide coefficients. Okay, divide coefficients. And so then you get y equals whatever that number is, the lead coefficient of the top divided by the lead coefficient of the bottom. So hopefully that will help you in your endeavors in memorizing how to do horizontal asymptotes, how to find them. So let's do one more case. This is the slant asymptote. The slant asymptote occurs when the degree of the numerator is exactly 1 greater than the degree of denominator. Okay, so the slant asymptote is a special case here where the bottom is bigger, is less than the top, so it's bigger on top, but it's bigger on top by exactly 1 degree. So like maybe I have some f of x equals like x squared plus 4 over some x minus 2, okay? The degree of the numerator is 2, the degree of the denominator is 1. So this will have a slant asymptote, and it's found by long division. Or you can use synthetic division if you remember how to do synthetic division. Okay? Go watch a video on synthetic or long division if you need help figuring out this. You know what? We might as well just run through it. We'll do it. So let's try to divide this. Synthetic division says I take this thing I'm dividing by. So I have x squared plus 4 divided by x minus 2. I set this piece equal to 0, and I solve. So x minus 2 equals 0, so x equals 2. So I put 2 in my box. Synthetic division, I got to look at the coefficients. Now I have a 1x squared, but I don't have any x terms, so I need to put the 0 there. And then I have the 4. So this is 1, 0, 4. And when I write this out, I bring the 1 down. 2 times 1 is 2. Add those, I get 2. 2 times 2 is 4. And this gets me 8. This is my remainder. This is my number. That's my x. Okay? So this is x plus 2 plus a remainder 8 over whatever I divided by. That's the x minus 2. So my my slant asymptote is almost equal to this, The issue is with asymptotes, we're talking about behavior. We're talking about end behavior. So the end behavior, what happens at end behavior, that's like plus or minus infinity, right? Well, plus or minus infinity to this term right here, if I put a really big number in for x, what's going to happen? This number, like maybe it's 8 over 10,000 minus 2. That's like 8 over 9,998. What type of number is that? Well, let's see. 8 divided by 9,998. That's a really small number. It's really close to 0. This thing is heading towards 0 on my end behavior. So here's what we do. For slant asymptotes, all you do is you do your little synthetic division and then get rid of the remainder, because the remainder is going to end up going to 0 at infinities. Okay? So this is your equation for your slant asymptote.